Problem 28 of our SAT calculator section. We have Micah and Raina. Micah and Raina each selected a random sample of students at their school, and they conducted a survey. It was about soft drink servings each student consumed the previous week. When you're reading these questions, it's important to note that all we need to know is that they asked some amount of servings. Okay, get the important information. It does not matter that it was at their school. It doesn't matter how many soft drinks they had. There's some quantity here, servings. Each student had consumed the previous week, so we have some time frame. Okay, previous weeks there's some time frame. Okay, we know the mean 7.1, margin of error 1.2. Okay, so just reading these questions, you can skip over some information. Like, you don't need these filler words like Micah's estimation of soft drink servings. You're just treating this like the mean of the quantity was 7.1. That will allow you to read these questions a little faster, and that just happens with practice. Raina estimated the mean number of soft drink servings was 0.83. So again, Raina estimated mean is 8.3, and the margin of error was 0.8. So I'm just looking for those keywords like margin of error, mean, numbers like 8.3, 8.3, and 0.8. Now, assuming they calculate the margin of error in the same exact way, there's different ways of calculating it. So assuming they use the same method, which of the following best explains why Raina has a smaller margin of error than Micah? So remember, Raina's margin of error, we have 0.8, was smaller than Micah's, which was 1.2. Okay, so why might that be? Okay, so let's look at the answers here. We have Raina's sample contained more students than Micah's. Remember, they each did their own survey. That's important here. So there might be a different number of students, maybe. Raina's sample contained more students who drink soft drinks than Micah's sample contained. Raina's sample contained more students who drink exactly 7 soft drink servings than Micah's sample contained. Or D, Raina's sample contained more students who drink exactly 8 soft drink servings than Micah's sample contained. That's a tongue twister. All right, so C and D look very similar. So anytime you have similar answers and there can only be one true answer, you want to be wary of that. So let's say this is true. Let's say Raina's sample did contain more students who drink exactly 7. Well, that would mean that D, but when Raina's sample contained exactly 8 soft drink servings, that means number 7 and 8 must be like significant. But our numbers are 7.1 and 8.3, so those can't be really relevant if we think about it. But even more so, we know that this is so specific that it doesn't deal with the margin of error. If it was 7 soft drinks more or 8 soft drinks more, we still have no idea what that is in relation to the quantities of soft drinks of the average of the survey. It could be 100 for Raina, and then 7 more exactly for Micah would be 93, or it could be Micah would have 0, and then all of Raina's had 7. So the quantity of the number matters. We don't know what the actual sample sizes are. So we want to relate the entire sample size, just off C and D, we know we want to relate the entire sample size to Micah's entire sample size. So we know it can't be C, it can't be D. Those are too specific. We want the entire sample size. So looking at A and B, if it's B, Raina's sample contained more students who drink soft drinks than Micah's sample. Remember that my cat is bumping my phone stand. That's why it's shaking. His name's Leo. We'll see if he can you ready? Oh, you saw his head for a second. That's Leo. So Raina's sample contained more students who drink soft drinks than Michael's sample contained. That might be relevant if that's not exactly what the survey was finding. So the amount that drink it should not affect the actual survey itself or the margin of error, because the survey results don't impact margin of error. However, the sample size will. So if Raina's sample contained more students than Micah's sample contained, so if the total number of Raina's sample size is larger than the total number of Micah's sample size, for example, let's say Raina's is a group of students and she has like tons more. This is all of Raina's students. You can see all these little dots. Okay? She has a huge sample size. And then Micah just interviewed like 3 people. That means R and M for Raina and Michael. If Raina had more people, we know that the more people we interview, the more likely we are to get an accurate representation of what the data is we're trying to collect. So for example, let's say these three people, let's say we have a survey about which grade is best, 6th grade, 7th grade, or 8th grade. And Raina and Michael interview 6th graders, 7th graders, and 8th graders. Michael, because he has such low numbers, he's only interviewing 3 people, he happens to get 3 6th graders. Those 6th graders are going to say their class is the best, most likely. So then 6th grade, according to Michael's survey, is the best class. Raina would get a more accurate distribution of students. More than likely, she has about 1/3 of each grade, which means that each grade will be equally represented, the population is better represented, and it's more likely to get a result of all grades equally saying they're all the best, unlike Micah's, who would be favored for 1. So it eliminates bias the more you have, which means that we want more students in order to lower our margin of error, which means our answer is going to be A.